Okay. Good evening, everyone. Myself Farhan Javed, and I am doing presentation of Lab 2 of embedded system for the team Phoenix Fire. Let's start the simulation. This is the input menu, which contains 5 sensors: sensor 0, 1, 2, 3, and 4. Sensor 0 denotes the extreme left sensor, and sensor 2 denotes the middle sensor, and sensor 1 denotes the sensor between the extreme left and middle sensor. Similarly, sensor 4 represents the extreme right sensor, and sensor 3 denotes the sensor between middle sensor and the extreme right sensor. And for output, we have 3 values: velocity of left motor, velocity of right motor, and the direction of the robot. So let's start the simulation. First, we will be giving the sensor to value 50. And so according to this, the robot is following a straight line, thin straight line. So it should go in the straight manner with velocity 100, and the direction should be 1 since it is moving forward. It satisfied the first value. Now we will be deviating our robot in the right direction by some little values, like let's say by 20. So yeah, the value of left motor is being decreased to 88 since we are deviating towards the left, and the value of direction is 2 here, which denotes that we are moving in left direction. Now again, let's try to increase this value by let's say 33. Yeah. So again, we can see that the value of left motor is being decreased because we need to deviate more towards left, and we will give the sensor one full value. We need more deviation towards right, towards the left. Yeah. So yeah, again, the value of left motor is being decreased. Now we want more deviation in the left direction. Extreme turn, the value of left motor will become 0. Left motor will stop, and the right motor will have the value 100, and we will extremely move in the left direction. Here the direction value of direction is 2. Okay. Now check for this condition again, that if our simulation is right or wrong. We will be decreasing the value of sensor 0, and again we will giving the same equation as of earlier, since we are deviating slightly, not quite slightly, but yeah, still this slightly in the left direction. So you'll get the value of left right motor as 73 and 100. Now again we will decrease the value of this to, let's say, 23. So yeah, again the value of left motor is being increased without changing these two, and at last we will be giving this sensor one value 0. So yeah, again the ideal case will be followed because the robot is moving in straight direction by detecting only the middle line. Okay, now let's try to deviate our robot in the right direction. So we'll gradually increase the value of sensor in the right direction. So let's try it by increasing till value, let's say 15. As we can see, the value of right motor is being decreased since we are taking turn in the right direction, and the value of direction is being changed to 3 because we are moving in the right direction. Now we will again gradually increase this value. Since this was 15, so we will put the value 30 here. The value of right motor is again decreased, and let's give it full value 50. So we are taking more than slight right turn. So the value of right motor is being decreased to 75, and the direction is still remains 3 because we are moving in the right direction. Now for the extreme case, instead of giving this a value 50, let's try to give it a value 14, since we will be moving in the right direction. So yeah, this value is being increased to 74 and 76, and after that we will be giving this the value extreme right condition. So we will be moving in the intersection in the right direction. So yeah, this will become 0. Right motor will become 0, and the direction will remain 3. Now again we will go back to our ideal case. This will become 0. So again we are getting the same result. We are moving in the right direction, and we will be decreasing this by 25. In this step, again the velocity of right motor is being increased. I mean, let's try to check for some random values, we say. give this value 30 and give this value as 27, give this value as 18. Okay, and let it be 0. So this means that our main focus is our direction is shifting towards left. Yeah, so the direction should be 2 and the velocity of left motor should be less than the velocity of right motor. As you can see, the velocity of left motor is 97, this one is 100 and this one is 2. So this is again correct. Now let's check for some other conditions. Here we will be giving this as value 50 and this again we will be giving as 50 and this will be giving as let's say 27. Yeah, let's say 27. So again we are shifting towards left since we are going to the extreme direction. So the velocity of left motor will be 0 and the right motor will be 100 and the direction will be 2. Now some last cases we will check. Till now we have all the cases covered are correct and let's give it all of them as value 0 and check only for the extreme condition. So yeah, so this should not change as we are getting the extreme left sensor, so we should move toward. Yeah, after simulating again we are getting same level. At last we will be checking for some middle values. Let's say set this to again 0 and let's say set this to 50 and set this to 50 and also set this to 50. So if we will check, we will get something like 192 and 3 because earlier we were moving towards left and now we are moving towards right. So this proves that in order to follow the straight line, we should be taking a slightly right turn to align in the straight line. So yeah, again, this is true. And now we are on the right track again because this is the almost ideal condition which we are following for the straight line because all three middle sensors are full. So we'll be following the straight line. So there are some little variations may be there because of the PID controller, but overall we have seen that our simulation model follows the correct simulation of all the given inputs and give the correct outputs from my side. And thank you.